You'll notice as you go through these worksheets that some of the examples are numbered differently. Some of them have 1, 2, 3s, A, B, C. Some of them don't even have a number or letter on them. So it's a little bit confusing, but just follow along on the worksheet and find where I'm starting. So this is example A. And here we're looking at rules of exponents. So your exponent rules that you need to focus on are, you've got x to the m times x to the n. That is x to the m plus n. Okay? Now the reason for that, and you don't have to write this down, but let's just look at, if we have x cubed times x squared, then that would be x times x times x times x times x, which is x to the fifth, exponents added. If we had x to the fifth over x to the third, that would be 5x's on top and 3 on the bottom. 3 sets cancel and you're left with 2. So that means that x to the m over x to the n is x to the m minus n. You subtract. X to the m to the n is x to the m times n. Reason for that, if you had a squared cubed, that would be a times a cubed. Well, that would be a times a times a times a times a times a, which would be a to the sixth. 2 times 3 is 6. Then let's see, what else do we have? This is kind of like distribution in a way. You can't do this with addition and subtraction. But when you're multiplying in here, then you can take the m and multiply it by each of those. So x to the am times y to the bm. And then we have quotients a to the x, or x to the a over y to the b, all to the m. You can also put that on the top and the bottom. So x to the am over x to the, y to the bm. Let's see, there's a couple more here. Move this over a bit. Maybe I'll just put it on the next page and we'll come back. So x to the negative m. What does that mean? That means 1 over x to the m. Now let me see if I can explain this. So 2 to the third power is 8, right? 2 squared is 4. 2 to the first power is 2. 2 to the 0th power, anything to the 0th power is 0. Actually, we don't even need that right there. Well, yeah. So what did we do to get from here to here and from here to here? Well, we divided by 2, right? So if we divide by 2 again, 2 divided by 2 is 1. That's 2 to the 0th. 3, 2, 1, 0. If we divide by 2 again, we get 1/2. So that's 3, 2, 1, 0, negative 1. And if we divide by 2 again, we get 1/4. That's 2 to the negative 2. Because 2 to the negative 2 would be 1 over 2 squared, which is 1 over 4. So that explains this rule, and it explains the rule x to the 0 is equal to 1. Anything to the 0 is always 1. So let's look at a few examples. The first one here, we're going to multiply, and we'll just start by multiplying 5 times 3. And then x squared times x cubed, that will be x to the 2 plus 3. And then y to the 5th times y to the 7th, that'll be y to the 5 plus 7. 5 times 3 is 15, times x to the 5th times y to the 12th. And that's it. For example B, we're going to divide. We'll divide 5 by 15, and we'll just simplify that in a minute. X to the 9th divided by x to the 3rd, that'll be x to the 9 minus 3. And y to the 5th divided by y will be y to the 5 minus, there's a 1 there. 5 divided by 15, simplify. Yes, you do have to simplify these fractions. And then x to the 6th, y to the 4th. Now this is okay. To make it look a little bit better, put the x to the 6th and y to the 4th on top and the 3 on the bottom. So it's all together in one piece. And then the last example, power to a power. Let's do what's in the parentheses first. You could put those powers on everything, but it gets you some really big numbers. So we'll start with 16 divided by 2. And then x to the 5th divided by x to the 3rd is x to the 5 minus 3. We'll raise to the 3rd power. 16 divided by 2 is 8. And then 5 minus 3 is 2. So we'll just essentially distribute the 3. 8 to the 3rd. Yes, you put you raise the 8 to the 3rd power also. Times x to the 2 times 3. 8 cubed is 512. Go ahead and write that out. X to the 6th. And that concludes the section on exponents.